What if I told you up and down don't actually exist in space? We were wrong about the shape of our solar system. Completely wrong. What's our solar system? Empty space. That's what we thought until we looked closer. Point down. Now imagine someone on the opposite side of Earth pointing in the exact opposite direction and calling it down too. That's when you realize something strange. Up and down only make sense on Earth. In space, those directions don't exist. And what we have recently discovered about what's above and below our solar system proves something even bigger. We misunderstood our place in space. For decades, astronomers taught something simple. Our solar system is flat. The planet orbits the Sun in a thin disk called the ecliptic plane. Everything moves in the same direction, same plane, nice and organized. So naturally we assumed that above and below that flat disk was mostly empty space, maybe a few comets, but nothing major. Clean, simple, predictable. But that idea started breaking in 2012. That is when Voyager 1 reached a boundary no spacecraft had ever crossed before. 11 billion miles away from the Sun. Suddenly everything changed. The solar wind disappeared, cosmic radiation increased, plasma density jumped dramatically. Voyager had crossed the heliopause, the edge of the Sun's influence. But here is the surprise. It was not where scientists expected it to be. And the shape was wrong. For years, scientists believed the heliosphere, the bubble around our solar system created by solar wind, looked like a comet, rounded at the front, long tail stretching behind. That's what models predicted. But in 2020, new data from Voyager, IBEX and Cassini changed everything. The heliosphere is not comet-shaped. It looks more like a crescent, almost like a squeezed croissant, twisted and warped by magnetic field from interstellar space. Not symmetrical, not clean, not simple. Even Voyager 1 and Voyager 2 crossed the boundary at slightly different distances. Same age, different conditions. Which means the age of our solar system is not fixed. It shifts. It changes depending on direction. So, what is above and below? Already, the answer is not empty space. It's distorted boundaries. But that's only the first layer. Because far beyond the planets, beyond the heliosphere, there is something much bigger. The Oort cloud, a massive spherical shell of icy objects surrounding our solar system in every direction. Not flat, not disc-shaped, spherical. It stretches from about 2000 astronomical units to possibly 100,000 astronomical units away, almost halfway to the nearest star. And here is the strange part. We have never directly seen it, not once. No telescope has captured an Oort cloud object unless it falls toward the sun and becomes a comet. But we know it's there because long period comets keep arriving from every direction above the solar system, below it, at impossible angles. Something is sending them inward, and new models suggest the Oort cloud is not just a simple cell. It may have a structure, density variations, regions shaped by the gravity of the Milky Way itself. That means the galaxy is pulling on the outer edges of our solar system, warping it, shaping it. So our solar system is not isolated. It's embedded inside the galaxy's forces. Now here is something even stranger. The flat plane where our planets orbit, it's tilted about 60 degrees compared to the Milky Way's disk. That means if you travel straight up from Earth's North Pole, you are not leaving the galaxy. You are cutting through it at an angle, heading towards billions of stars, nebulae, gas clouds, dense regions of space. So up does not mean away from everything. It just means one random direction chosen by the spin of the gas cloud that formed our Sun 4.6 billion years ago. If that cloud has spun differently, our up would point somewhere else entirely. Different stars, different constellations, different galactic structures. Direction is random. It only feels real because gravity gives us orientation on Earth. In space, there is no up, no down. Every star system has its own orientation. Every galaxy has its own plane. Every cluster is aligned differently. And Voyager 1, it won't even reach the inner edge of the Oort cloud for another 300 years. It will take around 30,000 years to pass through it completely. And during that entire journey, it will still technically be inside our solar system. Because the true boundary is not where the planets stop. It's where the sun's gravity finally loses against the Milky Way. That's around 100,000 to 200,000 astronomical units away. 1 to 3 light years. And we can't observe it directly. No telescope can see that far with clarity. No spacecraft will reach it in our lifetime. The true age of our solar system is invisible. And beyond that, other stars, other Oort clouds, possibly overlapping with ours, interstellar gas, magnetic fields, gravitational tides from the galaxy. There is no clean edge, no empty void above or below, just layers, nested structures, region where one influence slowly fades into another. We thought our solar system was a flat disk floating in empty space. Instead, it's a set of overlapping spheres embedded inside a galaxy shaped by enormous forces. And above and below, they are just human words, local references, useful on Earth, meaningless in deep space. So what's above and below our solar system? Not nothing, not empty space, but complex layer of structure we are only beginning to understand. And every time we think we have found the boundary, we discover another one. The universe keeps rewriting what we thought we knew. And we are still at the very beginning of figuring it out. If you enjoyed exploring ideas that make you question reality, make sure you subscribe. Because the deeper you look into space, the stranger it gets. And we have only just begun.